Welcome to my channel. In this video, we're going to be talking about titration. Titration is a technique used to determine the concentration of an unknown solution in the laboratory. So let's look at let's look at one problem. One of our problems says suppose a student was asked to titrate a solution of H2SO4 against 0.124 mole per dm³ sodium hydroxide, which is NaOH solution. The student titrated the acid against 10.0 cm³ portions of the NaOH solution and obtained an average titrate of 15.10 cm³. And so the question is saying calculate the concentration of the sulfuric acid in mole per dm³. So normally here in our titration, our acid here become, in this problem, our acid here is H2SO4, and our base here is sodium hydroxide, NaOH. So this reaction is an example of a neutralization reaction. So what we're going to do in this case is that we're going to be solving for our concentration of the unknown compound. What is our unknown compound here? Our unknown compound is sulfuric acid. Sulfuric acid becomes our unknown compound. But in solving this, we'll be using our titration equation. Titration equation here, this equation we're going to use, and I'm going to write it on the board so you can see. So our titration equation we're going to use will be, in this case, we could be CA VA and divided by CB VB will be giving us NA divided by NB. So in this case here, A over there stands for acid and B here stands for base, and same thing with this. This N stands for the number of mole in the equation. The number of mole in the equation will be giving us. So we're going to use this formula, and in using this formula, in this case, to solve for what I have is that I'm going to substitute in this reaction. So I'm going to write this reaction better and better solve. So I'm saying CA or VA divided by CB VB giving us NA divided by NB. So in this case, what we're going to do, we're going to cross multiply. In cross multiplying, we're going to have CAVA times NB, this times this, giving us this times this. We're going to get CBVB giving us NA. The question is saying we are looking for the concentration of the acid. So in this case, in order to find our concentration of the acid, we're going to divide both sides by VACB. So we divide both sides by VA and NB and CB, or VANB and VANB. So this is going to cancel this. So therefore, we're going to be left with CA to be equal to CB VB NA, or over VA times NB. This becomes our formula we're going to be using to solve for this problem. Now, in this case, in order for us to solve, what are we going to do in this case? Observing this reaction here, we're going to take into consideration here that we already have 2 mole of sodium hydroxide here, and we have 1 mole of sulfuric acid. Take note of this. So I'm going to write that up here, that Na is equals to 1 and NB is equals to 2. Then we can go ahead using this equation here to solve. Now, in solving our equation, so Ca will be equals to Cb. Earlier in the problem, the concentration of the base was equals to 0.125 mole per dm³. This was the concentration of the base. Now the volume of the base the volume of the base was 10.0 cm3. This was the volume of the base. Now the mole of the acid, is 1. The mole of the acid is 1, so we'll turn this by 1 and divide this. The volume of the acid becomes 15.10 cm3 times the mole of this times the mole of the base. The mole of the base here is just 2, which is this, is just 2. Now we're going to use this to solve. In solving, so the procedure is Ca will be equals to, in this case, CMQ, or normally CMQ will cancel CMQ, and then what we're going to do here is, if you times 0.25 times 10 times 1 and divide by 15, so in this case the answer you're going to get is 0.25 mole times 10 times 1, the answer you're going to get there, and then you're going to divide by 15.10 cm3 times 2. And this happening, you're going to get your answers coming up, and your answer is going to be 0.0414 mole per dmq. This becomes the concentration of the acid. So you're going to say, therefore, C of H2SO4 will be equal to 0.0414 mole per dmq in this case. This becomes the concentration of the acid. So let's look at one problem. In this problem, I'm going to give you this problem to take home, and maybe in our next video I'm going to try my best to solve, and I'm going to read this problem. Saying Q is a solution of HCl containing 0.12 mole DMQ. P is a solution of sodium carbonate of an unknown concentration. Solution Q was titrated against 25.0 cm3 portion of solution P, and an average titrate of 26.25 cm3 was obtained. Calculate the concentration of solution P in mole per dmq. You're going to use this formula. Similar problem, solution P, know what is solution P, solution Q, P